Okay, so today I'm going to teach y'all how to graph cubic functions. So let's take a look at the notes. Right here we have our a value and then the x value. H value, it's a cubic function, so it's cubed, and this is the k value. Your point of symmetry is your h and k value. On the h value, always flip the sign. So it's -1 becomes a 1, then you bring down the -1 here. It's 1, -1. Here's what the parent function looks like, and then here's this function. And a parent function is right here in the black. And the transformation, we reflect it over the x-axis here. There's a vertical stretch of 2 because of this 2. It was right 1 and down 1 because of the h and k values. And then over here, domain and range is always -infinity to infinity. And the end behavior as x approaches -infinity, f of x approaches infinity, and as x approaches infinity, f of x approaches -infinity. Let's take a look at some examples here. So we have y equals x plus 3 cubed plus 5. So your a value, since there's no number, that's a 1. And then your h value is going to become -3, and your k value is 5. So your point of symmetry is -3, 5. So on the graph here, don't have numbers, so we'll just guess. So -3, 5 is going to be somewhere over here. And basically, when the a value is 1, you go over 1 and up 1 and down 1 and over 1 like this. So you make one of these, and it's going to look like this, with a squiggly through those and arrows here because it doesn't end. So the end behavior is as x approaches infinity, f of x approaches -infinity, and the opposite of that, so vice versa. And then on here we have a little harder example. So we have a bigger a value now, a value of 7. Then the h value is going to be -1/2, and the k value is 3. So the point of symmetry is at -1/2 and 3. So on the graph here, go ahead and graph that at -1/2 and 3, which is like right here. And since the a value here is 7, take a look at the notes, see what it does. Whenever you have a whole number, it makes the graph wider. Like on this example here, it's or whenever you have a whole number like 2, it makes it narrower. So like here, y equals 3. The parent function's usually like this. Now it's a lot narrower like this, like on this example right here. So 7, you're going to go, instead of over 1, up 1, you're going to go over 1 and up 7. Oops. Over 1 and up 7, which would be like up here. And then down 1 over 7, which would be like down here. So it's going to look something like this. And then down here, here's a hard example. Now we have this inside the parentheses, and your a value is 3/4. The h value is -7, and k is 6. So point of symmetry, -7, 6. So on the graph here, that's like over here. And now, since we have a fraction, it makes the graph wider. So basically what you're going to do, instead of over 1 and up whatever, it's over 4 and up 3 like this, and then down 3 and over 4 like this. So it looks something like this with the arrows right there. And then the end behavior is as x approaches infinity, f of x approaches infinity on this one, since we're going up and to the right, And then as x approaches negative infinity, f of x approaches negative infinity, since we're going down left. And that's how you graph cubic functions. Stop the video.